Alright, we're going to talk about absolute value inequalities. Remember when we did absolute values, we said the only things that can come out are positive and zero. Because absolute value is talking the distance away from zero. So if you're at zero, it's zero. And then up any positive number, any number, it's going to come out positive. Because it doesn't matter if you're on the negative side or the positive side. They both have the same distance away from zero. So we just use positive. When we were doing absolute value equations, remember it was impossible. Remember the first thing we always wanted to do was isolate the absolute value. That's when we were solving, we're going to do the same thing now. When we're solving these absolute value inequalities, you're also going to isolate the absolute value. Remember, when we're solving absolute value or just solving inequalities, remember that when you multiply or divide by a negative, you have to switch the inequality. So hopefully remember that. But we're still going to do these two things, isolate the absolute value, but you just have to be careful if you're going to be multiplying or dividing by negative, you're going to have to switch the inequality. And then remember we had to watch out for, once we isolated it, if it was equal to a negative, we knew that that was impossible. This was the only thing you had to watch out for. But with inequalities, you're going to have a lot more to think about. And don't forget, when we solved an equation like this, the absolute value of x is equal to 2, this had two different answers. It was 2 and the negative of that. So we're going to do that again with absolute value inequalities. This is going to be the positive or negative answer. But there's going to be one extra thing that you're going to have to do. But let's just talk about a couple of the scenarios that we need to look out for. And the main idea is you want to look out for 0 and a negative number. So these are the things you want to look out for. Let me box that. So you want to watch out when that happens. Whenever you see 0 or a negative number after you're done isolating the absolute value. Because if we have a situation like this, remember, the things that come out of an absolute value are either positive or 0. And how many numbers are greater than 0? There's an infinite amount of numbers that, so if you guys don't remember the symbol, this means all real numbers, because there's an infinite amount of numbers that are bigger than 0. And this is both, because if we put a negative 3 in here, what's going to come out is positive 3, which is also bigger than 0. We put in positive 3, we're going to also get positive 3 back out, which is also greater than 0. But the only thing this cannot be equal to is 0. Because we know the only things that come out of absolute value are either positive or 0. But here, the only answers that make this inequality true, that this side, remember, is bigger, this side has to be smaller. All the positive numbers are bigger than 0, but 0 is not equal to 0. But if we have this, absolute value is greater than or equal to 0, we already know almost every single number is bigger than 0 except 0. But 0 is equal to 0. So here, every single number works now. Every real number will be a solution to a problem like this. So that's why I said you want to watch out for 0. But then you want to be careful for when the absolute value of x is less than 0. Here, there is no, because everything that's going to come out is positive, and then this side has to be smaller than 0. The only numbers that are smaller than 0 are the negatives. The only thing that's going to come out of this absolute value is positive, then this has no solution. Remember, this is after you're done isolating the absolute value. You want to watch out for 0. And then there's this situation. The absolute value of x is less than or equal to 0. And the only solution here, so this would be your solution set. This whole thing would be your solution set here. Your whole solution here is all real numbers except 0. This has no solution, so you just leave these empty. And here the only solution is 0. Because the only number that can be equal to 0 is 0. Because we know what comes out of the absolute value is a positive and 0. But now these are just 4 scenarios for 0. Now we have to think about the scenarios for negatives. So if we look at an absolute value is less than a negative, again, that's any negative number. That could be a decimal, it could be a fraction, it could be a whole number. The idea is just, are positive numbers smaller than negative numbers? And remember, that's impossible. So this has no solution. Because positive numbers are bigger. Remember, this has a smaller side. This has to be the bigger side. And this is always going to come out as positive and 0. Which 0 is also bigger than negative numbers. So there's no solution here. Also for this one, I'll just group them together. Because there is no, again, the only thing that are come out are positive or 0. And 0 is not equal to a negative, and it's not smaller than negative. Positives won't be equal to negatives, and they're not smaller than negatives. So let's look at this scenario here. Positives. Remember, the thing that's going to come out of here are positive numbers and 0. So that means what numbers are bigger than negatives, and positives are always bigger than negatives, and then 0 is also bigger than a negative. So in this scenario, again, we have all real numbers, meaning the whole number line is a solution to this problem. And if we look at greater than or equal to a negative, here it's still all real numbers. Even though none of these will be equal to a negative, remember this greater than or equal to is less than or equal to. You only need to satisfy one of them, not both of them. So 0 and any positive number will always satisfy the greater than part. And nothing will satisfy the equal to part, but it doesn't have to. So those go sort of hand in hand. So technically there's 1, 2, 3, 4, 5, 6 scenarios. But those 6 scenarios come from once you're done isolating it. If you see a 0 or a negative number, you want to stop and think about what these represent. Think about what the inequality is asking for. Smaller, bigger, bigger, smaller, bigger, smaller, smaller, bigger. This side has to be smaller, this side has to be bigger. And just think about the relation between positive and negative numbers, 0 and negative numbers, positive and 0, 0 and 0. So you have, and these are the different sort of answers. And it doesn't matter what's in here. Because you can have the absolute value of 2x minus 5. And then this problem right here, less than or equal to 0. It doesn't matter that there's all this going on inside the absolute value. Because we already know it's either going to be a positive or 0 that comes out of it. So if you already know that's going to happen, then you can already assume the only thing solution this is going to have is 0. Because no positive number is less than 0, but 0 is equal to 0. So just keep that in mind. So whenever you're isolating, that's what you want to watch out for. Positive. You want to watch out for 0 and negative, and think about the relation between negative and positive numbers, negative with 0, 0 with positive numbers, and 0 with itself. Alright, these are just things to think about when we're solving absolute value inequalities. But now, when we actually solve them, when I said we have to do this idea again, where once we were done isolating the absolute value, we always broke it up into two different problems. So we're going to do the same thing. The only difference now is, so you're going to have a positive and a negative. That's not going to change. You're going to have your inequality, again, just some random one. And then you're still going to make your two different ones. But that's after you watch out if you see a 0 or a negative. Once it's isolated, this is the first thing you should think about. Is there a 0 or a negative? That's why I told you guys when we're doing these, there's only one that you got to watch out for. Now there's 1, 2, 3, 4, 5, 6 different ones you have to watch out for. But it comes from 0 and a negative. So the only difference is everything, once you take out the absolute value, everything is the same. So you still make the same thing with when we were doing absolute value equations. There was always that one that was the same. But then the next one is the one that had the negative of that constant. But this is the only thing we need to add. Since we're switching the sign, we have to switch the inequality as well. That's the only thing we're going to do. And that goes for this symbol, that symbol, this, and that. All these symbols. That there's always the original one, and then once you switch the sign, you have to switch the inequality as well. But then once you see one of these scenarios, you can just give one of these answers depending what you have. But let's look at an example of all this. So let's see. Did you work out yours? All right, but at the same time, when we're isolating it, don't forget that if it involves either dividing or multiplying by a negative, you want to make sure you switch the inequality around. That's just because we learned this rule from solving inequalities. This switching is happening because it's an absolute value inequality. So don't mix these two ideas up. This is because we come up with two different problems. This is just because as you're isolating, if this happens, you have to switch the inequality, which then it would switch here if you have to. So for example, let's solve. So we have 2 absolute value of 6 minus m less than minus 3 less than 7. So again, everything is the same as an equation. That was the only difference that you ought to watch out for when we were solving inequalities. So we still have to do everything pretty much the same. So I want to take care of this. I want to isolate this first. So that means I need to add 3. Here we're going to cancel. So we have 2 absolute value of 6 minus m less than. Remember, adding, subtracting, multiplying, dividing doesn't change anything. It's only when you multiply or divide by a negative. So we have 10 now. I still want to get rid of this 2 because by isolating, I want there to be nothing in front, not even a negative. I want it to be completely positive and no numbers in front. So now I divide by 2. This isn't canceling here. These are just simplifying to 1. Which now I'm left with absolute value of 6 minus m less than 5. So again, I divided by a positive number. Nothing has to change. So now we look at here. This is where we get our 2 different inequalities. Well, there's one that's going to look exactly the same when you take out these absolute value. Nothing is changing. And then the second one is when your sign for the number changes. So your inequality has to change. Now, I didn't say, I kind of just jumped to this just because I noticed there was no 0 and no negative number. So that's what I mean. When there's no 0, no negative number, you can just jump to doing the problem, isolate it, and then make your 2 inequalities just the same way we did before, but only this sort of extra step here where you have to switch the inequality when you're switching the sign of the number and not because of that you're multiplying or dividing. So now let's solve these. We have to solve for m, so let's subtract by 6. These cancel. We have negative m less than negative 1. So now we're going to divide by negative 1 to both sides. These simplify to positive because a negative divided by a negative is positive. 1 divided by 1 is 1. But you need to remember that you divided by a negative. So that means the inequality is going to switch. But it's switching because of this, not here. This, we already switched it already because it went from 5 to negative 5. This is because we're dividing by a negative. We're switching again. So don't mix those ideas up. Now here, we have to subtract by 6 as well. These cancel. I have negative. Let me split it there. Negative m greater than negative 11. And we have to divide by negative 1. So again, since we're dividing by a negative, we're going to switch the inequality. And then we're left with 11. So now remember, when we were solving our inequalities, we had 3 different solutions. We either had the graph, interval notation, and set notation. So let me do that. Try to fit it in here. I'm going to do it right here. I'm going to use this line that I made. So the only numbers we have to reference is 1 and 11. And for both of these, this doesn't have an equal to in any of these. So both of these are going to have an open circle. And this is saying that m has to be bigger than 1. So remember, the numbers that are bigger are always on the right. But here it says that m also has to be smaller than 11. Remember, there's not 2 different m's. This was just trying to find the solution to this one variable here. So that means you have to satisfy both of these inequalities. Almost like when we did a compound inequality, you have to satisfy both of these for this solution. So m also has to be smaller than 11. These are open circles. I know they're like filling in, but remember, open circles at 11, and then it's just everything in between. Because the numbers that are smaller than 11 are on the left, but then at the same time, the numbers that are bigger than 1 are on the right. So all your solutions are inside of here. And remember, when we do our interval notation, it's from least to greatest. So we start at 1, and then stop at 11. But since they're not, both of these are not included, parentheses are on both. For set notation, remember, it's just m, since that's the variable we're talking about, such that I'm going to talk about the variable on this side, and that's that m has to be greater than 1, and m has to be less than 11. Sorry to squeeze it in there. So all I grabbed is these two and put it inside of here. So again, you want to watch. Sorry, got cut off there. So we just put these inside of here. But let's do another example. So that one's like crammed in there. But isolate, watch out for if you're multiplying or dividing by a negative, and then make your two inequalities. But you have to switch the sign of the number, and then you have to switch your inequality. So let's look at another example, which is, sorry, we have -4 greater than or equal to -2 absolute value of 3x plus 1, close your absolute value. Alright, so we want to isolate our inequality. So here's our inequality. The only thing in the way of this inequality is this -2. So I'm going to divide by -2 to both sides. But remember, when you're dividing or multiplying by a negative, you have to switch your inequality. We haven't even isolated yet to try to switch the inequality. This is just because you're dividing by a negative. This is going to simplify to +2. This is going to switch to less than or equal to, and this is going to simplify to just absolute value of 3x plus 1. But now we have to look, is this number 0 or negative? Those are things we want to watch out for, 0 or negative. Since that is a +2, that's not 0 or negative, we can continue with making our two different inequalities. Remember, it doesn't matter the absolute values on the right-hand side. Everything is still the same. You're going to have 2 less than or equal to 3x plus 1. Remember, 1's always exactly the same way this is written. The next one is where you switch the sign of your number. That means you're going to switch the inequality again. That's just because we're making 2. That's why we're switching the inequality. This was because you were dividing by a negative. Now we have our 3x plus 1. And now you just want to isolate your variable. It doesn't matter on which side it is. So I'm going to subtract 1 on both sides. That leaves me with 1 is less than or equal to 3x. Now I have to divide by 3. Again, dividing, all that's fine. As long as it's not a negative, there's nothing you need to do. That means 1/3 is less than or equal to x. Now we go on this side, we subtract by 1. Subtract by 1. That gives us -3 is greater than or equal to 3x. Same as before, we divide by 3. That gives us -1 is greater than or equal to x. So we have to do our solution. Again, you either do a graph interval notation or set notation. So the graph will look like this. The only numbers we have to reference is -1 and 1/3. I already know the negative is on the left because negatives are smaller than positives. So you don't need to know exactly where all these numbers. You should know, but if you don't, you should just know which number is bigger and which one is smaller. Because that's going to dictate which one's on the left and which one's on the right. So for both of these, they have the equal to part. So that means for both of these, you're going to have a closed circle on them. But now, remember, we have to satisfy, there's only one variable to begin with. So we have to satisfy both of these inequalities for the exact same variable. So this is saying that, remember, this is we already took care of the equal to part, that's a closed circle, equal to part, that's a closed circle. But remember, this side is the bigger side, this is the smaller side, because it closes on the smaller side, it opens to the bigger side. So this is saying that x has to be bigger than 1/3. And remember, bigger numbers are always on the right. And this is saying x has to be smaller than -1. Smaller numbers, so smaller than -1. Smaller numbers are always on the left. And that would be your solution. In interval notation, it's slightly different because now there's two different intervals that are going on. This looks like it's going to -infinity, stops at -1, and this one starts at 1/3 and then goes to positive infinity, because this is just starting from from least to greatest, least to greatest. But since this is a closed circle and it's equal to both of them, they're going to have a bracket and a bracket around them. Remember, we always put parentheses around around infinity. But now we have to remember, this is still the solution for one variable. It wasn't two different variables. So it has to look like one continuous solution. And the only way to do that is to do this U right here, which is called a union. It's just putting where this one ended, putting where this one started, and uniting them together so it looks like one fluid solution. Let me show you on this sheet of paper, see if it makes sense. So let's see this here. Imagine you have this number line, but then if you cut it off in these two places, so at -1 and 1/3, but you want to put them together so that they end up looking, let me put it in view. So you want to fold them together so they end up looking like they are one continuous sort of number line. That's the idea. Because look, we're chopping off everything that's in the middle. Because then that's the idea. You're unioning these two parts, and that ends up being your solution. All these numbers, including -1 and including 1/3. And that makes a U shape. Let me make that a little better. Sorry, I'm trying to fix it. So, we're unioning them together, and if you look there, they make a U. It's just like this U here, making a union. Because we're putting these two together, and we're unioning them. So, I don't know, hopefully that helps. So, here, union, U. I hope you guys can see that U that it makes. Right there. Alright. And then for set notation, I'll put it up here, x such that, and you have to put these two. It's greater than or equal to x, and it's less greater than or equal to -1 is greater than or equal to x. And that's it. Alright. Let's do a couple more to point out to something. So let's look at, we have, still solving. Let's say we have x plus 2 plus 4 less than 0. Alright, so remember, we need to isolate the variable first. So that's going to be, let's subtract by 4 to both sides. This cancels. When that cancels, you're left with x plus 2 less than -4. So this is where we need to stop. We didn't need to stop here because that was a positive number. Here is a negative, and that's what I said you want to stop for. Negative numbers. Now you want C is, remember, the only thing that will come out of here is either a 0 or a positive number. And we know, is 0 smaller than a negative? No. Are positive numbers smaller than negative numbers? No. Hence, there will be no solution here. There's no value of x. Regardless of what's going on in here, we know that what's going to come out is either going to be a 0 or a positive number, which both are not smaller than negatives. So that's what you want to watch out for. So that would be, you would just put your braces empty because there is no solution in them. So, and look at one more example, and that would be, let's say we have absolute value 3 absolute value of x minus 5 greater than 0. So remember, we want to isolate our variables first. Our absolute value. So we divide by 3 to both sides. That leaves the absolute value of x minus 5. 0 divided by 3 is still 0. And we have to stop. Again, like I said, you want to stop whenever you see a 0 or a negative. After you're done isolating, you want to stop and think about this. Remember, the only things that can come out of absolute value, regardless if there's this -5 here, that was that positive 2 there, the only thing that can come out is 0 or a positive number. And then if I think about would be 0 greater than 0? No. Are positive numbers greater than 0? Yes. So your solution will actually be x such that x is all real numbers except 0. Just sort of writing it all out. So this is saying that x can be any number on the number line. It just cannot be 0. So if you were to graph that, it would look something like this. You would have an open circle at 0, and it would be everything to the right, everything to the left. If you were to do this in interval notation, you have two separate intervals. It's that same thing. It's this union, but the union is happening at 0. So you're sort of breaking off these two different intervals, and it's like a very small union. Very, very small. Because all you're taking away is 0. So you can keep making that line. So it's just a very little union. Hence, you'd see a very little U. Hope you guys can see it. So that would look like from negative infinity. I'll do it right here. Negative infinity to 0. But then we have to stop at 0. Then we start at 0. And then we go to positive infinity. But since it's open circle at 0, it's parentheses. And we always put parentheses around infinities. And then you union these two parts together. This had no solution, so that's all you have to write. But this is how you write in set notation. This would be how your graph would look, because it's all of them, just not 0. And this is how in interval notation it's going to look. Alright, and that's pretty much it for 1.7. If you have any questions, I'll be on my office hours tomorrow at 9 in the morning. I'll send the email out. Watch out for that. Let me give you some homework really quick. Alright, here's your homework. 47, 49, 51, 53, 55, 61, and 65. So only 7 problems. So, again, this is just continuing the 1.7 from last time. Alright, if you have any questions, email me or just be at my office hours. Have a good day.